Very few students scored full marks in their A-level in this question last summer. Don't let it happen to you. In their report after the exam last year, the examiners said that this question proved to be a challenge for the majority of candidates, and full marks were not common. There were also a number of blank responses seen. Oh dear. Let's make sure it doesn't happen to you. Let's read it through. It says, prove, using algebra, that n squared plus 5n is even for all natural numbers n. So what do we mean by that? We mean 1, 2, 3, 4, 5, and so on. So we're trying to prove that this is even. So it's going to make sense for us to break this up into two cases. One case, case 1, where n is even, and the other case, case 2, where n is odd. What makes a number even? Let's think about case number 1. A number is even if it's 2 times an integer. So we can write n equals 2k for some natural number n. Let's consider what n squared plus 5n would be. Well, n is 2k, so 2k all squared plus 5 times 2k. If we apply the square to both the 2 and the k, we get 4k squared plus 10k. And we're trying to show that this is even. So let's factorise it. We see that this term and this term are both in the 2 times table, and while we're at it, we may as well factor out the k as well. So the fact that we've factored out this 2 here, and this is an integer, means that this whole thing must be even. So we've proved that in case 1, the case where n was even, n is 2k, then n squared plus 5n is also even. But that's not enough. We've only considered case 1 where n is even. We also need to consider case 2 where n is odd. What makes a number odd? Well, an odd number is one more than an even number. If our even number was 2k, then one more would be 2k plus 1 for some integer k. So let's consider what n squared plus 5n would be. Well, n is 2k plus 1, so it's 2k plus 1 all squared plus 5 times the same thing. If we expand the square bracket here, being really careful to remember that there's going to be 3 terms, don't forget that middle term, we'll get this. And again, if we expand here, we'll get this. If we simplify, we get this. And remember what we're trying to do? We're trying to show that this is even. In other words, 2 times an integer. So we can factor out the 2 and just make a note, a conclusion that this is even.